With factoring by finding the GCF. We are going to spend the rest of the time factoring up until spring break, and then you'll have a test. So you guys need to understand that factoring is a big part of Algebra 2. This is not easy for everybody. It's a lot of steps and a lot of work. Yes, guess what? I'm sure that Photomath will do this for you. Is that smart to do that? No. I can check myself. No.
I can check on the homework.
Please stop doing stuff with Photomath. It's not helping you guys learn. Do you understand me? I'm not sure that it will work or not on this, but I can try it and see. Not right now. So, just so you guys are aware, some definitions. A prime number is a whole number greater than 1 whose only factors are 1 in itself, meaning it can only multiply by 1 in itself. So the number 2, the number 3, the number 5, 7, 11.
Those prime numbers.
Those are 13, yes, prime numbers. A composite number. A composite number is a whole number greater than 1 that is not prime. 0 and 1 are not prime or composite. So, like the number 4 can be multiplied by 1 and 4 and 2 and 2. So that makes it composite because it's more than 1 in itself. Finally, the prime factorization means that it's a monomial that is expressed as the product of prime numbers and variables. So we will talk about what that means in a second here. So first of all, write the prime factorization of each integer. You may use exponents here. So that means we're going to do a factor tree. So what times what is 84?
7,
Number.
7 and 12.
What is it?
Good job, Justin. I can do it.
Pretty good.
What and what is 12?
6 and 2.
And?
3 and 2.
Back to these dang factors.
I love factor trees.
So how many 2's do we have?
2.
So that can be written as 2 to the second times 3 times 7.
Ooh. Is that fun?
That is a prime factorization of 84.
This has to be written in standard form or whatever it's called.
It's not technically standard form, that's just least to greatest. Because there's no variables or anything involved with this. Okay. This negative here just means that we will multiply by -1 in our final answer. What goes into 132?
11, 12.
3 and 44.
And what goes into 12?
6 and 2.
And 6 is? So remember this negative here? Our prime factorization needs to have that negative there. So it's -1 times 2 times 2 times 3 times 11. We have multiple 2's. How many do we have?
2.
So that's 2 squared times 11 times 3 times 11. That is the prime factorization that will get us back to the original. So prime factorization just means the same, or the prime numbers that multiply to get you back to that number.
Where's -1?
The -1 comes from the fact that the problem started off as negative. So we need to multiply this by -1 to make this negative in the end. Because negative times positive. Okay, so let's talk about the prime factorization for these here with variables, but we cannot, how come there's, oh, you've been doing it. You cannot use exponents this time. So, we do a factor tree for 8. What times what is 8? For whatever reason, if you need to go get some, you can. For whatever reason, a lot of you guys on your factor trees, I noticed in the last unit, we're stopping at 4. Is 4 a prime number?
No.
No. What times what is 4? 2. And we're not going to write this with exponents. So we're going to write that as 2 times 2 times 2. How many x's do I have?
No x's. 3. Wait, yeah.
So we list out 3 x's. And how many y's do I have?
1.
So the prime factorization of that is 2 times 2 times 2, x times x times x, and y.
use this one.
I mean, it's good to know like what goes into things if you're like dividing numbers and stuff in stores and everything. Like if you're getting multiples of things. Actually, no. This would make sense. This actually does make sense because you're looking for like if you're buying multiples of things and you need to divide things out or like try to figure out like what would be a better price in a store. Like it's good to know how to do this kind of stuff. Okay. So what goes into 26?
13 and 2.
And then we have this negative here. So that's going to be a -1 times 2 times 13. How many R's?
1.
How many S's?
1.
How many T's?
2.
You can stop complaining now. All right, what goes into 20? And what goes into 4? And then this negative here drops down. And we have -1 times 2 times 2 times 5. How many X's?
2.
How many Y's?
4.
And how many Z's?
1. Sounds like fun.
Yes, because it's the prime factorization, so it's all the prime things being multiplied together. If you multiply the numbers together, you're just going to get back to this. We're undoing this.
Do that's like an answer to a problem?
Right. 2 is already prime, so that's circled. How many X's do I have?
1.
How many Y's? How many Z's? You will not be doing this directly on your homework. We're using this to show you guys how to look for the GCF when you get to factoring. And this part is actually, guys, can we stop? This part is not actually on your homework. This is to get you guys used to this stuff so we can look for those GCFs inside of your numbers. So when multiplying, remember 2x times the quantity x to the third times 4 is 2x to the fourth, because 2 times 1 is 2. And x to the first times x to the third is x to the fourth, 1 plus 3. And then 2 times 4 is 8. X doesn't have anything to add with, so that's x. So we are going to learn how to factor. Factoring is undoing the multiplication. So look at this. We are left with 2x to the fourth plus 8x. You guys see that? What is the biggest number that goes into 2 and 8?
2, 4, 2.
2. This is called the GCF, by the way. Greatest common factor. How many x's can you take out? So this is where it gets confusing with the variables. So some teachers will list it out. I'm going to try to avoid that because sometimes I think that's confusing. Maybe it won't be, and if you guys come in for extra help, I'll show you it that way if this doesn't make sense to you. But, so how I equate this. So if you're going to be doing something illegal like stealing, and somebody has $4 in their pocket, and somebody has $1 in their pocket, and you have to steal the same amount from each person, can you take $4 from somebody that has $1?
So you have to take $1.
No. The most you can take is how many dollars?
1.
1, because they both have $1. So how many x's can you take?
1.
So we can only take an x out of that because they both only have an x in common. So our GCF is 2x. Do you see this 2x right here?
Yeah.
That goes out front. This is called factoring. So we take that GCF out. And then, to get what's in the inside, we divide. What is 2 divided by 2?
1.
Good. What is x to the fourth divided by x? We subtract those exponents when we divide. 4 minus 1 is 3. We divide 8x by 2. 8 divided by 2 is?
4.
X divided by x is?
0.
It's 1, actually, so that just stays there. Doesn't this the same thing as this?
Yeah.
So do you see how factoring, which is down here, is undoing what we did up here? So it's the opposite of what we were doing before, okay? So find the GCF first. So this is called the GCF, the greatest common factor, which we said the biggest number and biggest number of variables that come out. And multiply the GCF by the polynomial that will get you back to the original. That means divide each term by the GCF. Connor, are you sure? 'Cause I can help you.
Yeah, I know.
Huh?
You didn't divide them.
Yeah, I did. I showed it on the board up there. I did 2x to the 4th divided by 2x and 8x divided by 2x. Do you see that? Like the blue and purple together?
Oh, and then you just get.
And that gives you what you're multiplying by. Okay. So let's practice this skill. Let's practice this undoing of the multiplication known as factoring. So find the greatest common factor of each, then factor. So the first thing we're going to do is state our GCF. Your answer is going to look like this. The GCF will be out front, and the divided terms go inside the parentheses. So when you have your answer, it will have a GCF out front, and inside the parentheses are the divided terms. Do you guys understand what I'm saying there? Based on the last thing I did here? Do you see how the GCF was out front? And then our divided terms were inside the parentheses? So that's what we're going to look like there. So, what is my greatest common factor here? So we're going to start there. So the biggest number that comes out of 18 and 12 is? Why not 12? Right, 18 divided by 12 will give you a decimal. We want it to be a whole number, and you have to choose the biggest number. So if one of you would have told me 3, I would have said that's a factor, but it's not the greatest common factor. So it's the biggest number that goes into it. So it's still considered a factor, but we want the biggest number that goes into both. So we look at the variables. This one has an X. Does this one have an X?
No.
So this is like saying I have $1 and no dollars. Can you steal something from somebody if they don't have it? No. So can we take any X's out?
No.
I know, I'm not telling you to steal, I promise.
I like stealing.
So,
Brad's teaching us to steal.
I know.
All the time.
So,
Brad get caught stealing.
this person has $1 and this person has $1. What is the most amount of dollars you can take out of each person's pocket? 1. So how many Y's can we take out?
1.
Again, I'm not telling you to steal. It's like at the beginning of shows that are like, do not try this at home. That's the same thing I'm trying to give you
The fact
guys.
that you're putting overemphasis on it makes me feel like I should steal.
All right, guys. So, we know based on this up here that we put the GCF out front, right? So we put the GCF out front, and we do some parentheses here. So I divide by 6y. On both terms by 6y. 18 divided by 6 is
3.
x doesn't have anything to divide with, so that will stay x. And y divided by y is 1, so that stays there. Did you say 2?
No.
Okay. I'm just making sure you're okay. 12 divided by 6 is
2.
and y divided by y is
1.
Can you stop?
I have something.
No, you don't.
How do you know?
Because you're doing it at the same time every time. And that is your answer right here in this box. Please ask questions because this can get confusing really easily, I mean. Whoever's music is on needs to be turned off. Okay, that's fine. I just asked you to turn it off. So the first thing we look for is the GCF. What is the biggest number that comes out of 27 and 15?
3.
Yep, 3 does, because I would try 9, but does 9 go into 15?
No.
No, so 3 is the biggest number. Okay, this person has $2 and this person has $2. What is the most amount of money you can take?
2.
So we can take out 2 A's. I know, like what is that going to do for you? I don't know, but that's how like a lot of thieves start when they steal credit cards though. They like do like small transactions first to see if people catch them, and then they do a huge one. Because people's credit cards have been like, I've had credit cards and stuff stolen before, like IDs and stuff. So what they start off, that's why you should check your bank accounts all the time. I don't do that. I'm telling you this to make you guys aware, like when you have your own debit cards and credit cards one day, to like be aware of those things and check your accounts.
We know your identity.
Huh?
My mom's told me to never get a credit card.
Well, credit, you still need credit to buy things is the problem. If you have a credit card, you should pay it off every single month.
She says that she has to pay off like $700 a month because of her credit card, and she said it's the worst mistake she ever made.
Right, and I mean, when I've had credit cards, I've always paid them off. But you need credit to buy cars and to buy like houses and stuff, so you kind of do need a credit card.
But don't if you don't pay off the debts, doesn't your credit go
Your credit
down?
score goes down, but if you don't have a credit score at all, they don't know how to, you know what I mean, if you're going to pay things back or not.
Big things you have to have credit.
Yeah.
Right, but that just, so what you can do to use a credit card smart is just use it like it's cash, basically. That means that every month you pay the whole entire bill off. Does that make sense? So then you're never going to have to worry about the debt.
Okay.
Don't do things like put like $7,000 of something on there and know that you're not going to be able to pay back.
Right.
Does that make sense?
Yeah.
Okay. Anyways, on to another topic, but that's real life and that's a smart thing to know. So, how many B's can I take? One. This one does not have two to take, does it? No, so we can only take one. So the GCF goes out front. We put our parentheses in, and we divide by 3a squared b for both pieces. So, 27 divided by 3 is? A squared divided by a squared is? 1. B divided by b is?
1.
Good. Negative 15 divided by 3 is?
Negative 5.
A squared divided by a squared is?
1.
B squared divided by b is?
B.
Just a single b.
B. 1 B.
2 minus 1 is 1. That's where that came from. So look at those problems so far. See what questions you have, because as I've already heard somebody say, this can get really challenging and tricky, so you guys need to know what you're doing. Factoring is a huge deal in Algebra 2. Like, you start off factoring from day one, and if you don't know how to factor, you're going to be in trouble in Algebra 2.
Really? That's really scary.
Okay. 30, you have to. 36y plus 27x squared y. What is my GCF, Colin?
9.
I'm asking Colin.
Alright, 9.
Yeah, so I heard somebody say 3, but you're right that it's 9. Stop. Seriously. So 3 is not the greatest common factor. It is a factor, but you can take a bigger number out, and that is 9. So we have to be careful there. Colin, can you take any x's out?
No.
No, because 36y doesn't have one. Can you take any y's out?
Yes.
How many?
1.
They both have 1, so you can take 1.
And I thought I didn't get this.
You're doing good. Okay, Justin Crater, you're going to help me with the inside part. So I'm dividing by 9y. So 36 divided by 9y is? Y divided by y is? 1. So that doesn't have anything there. Okay, what's 27x squared y divided by 9y?
3.
Yes, because it doesn't have anything it's dividing. Any y's? No, because y divided by y is 1. So that is our final answer. Okay, there's 3 terms, which means those pieces need to be in all 3 places. So Kaylee, what is my GCF of number 4? So the biggest number that can be pulled from 28, 63, and 91. So 7 goes into 91, I'm not, okay. You said how many times?
13.
Yeah, and 13 doesn't go in all those, so that's perfect. Okay. How many A's can I take out?
0.
I'm still talking to Kaylee.
1.
So there's an A here, an A here. Is there an A in this last one to take?
No.
So can you take any A's out? Do you see that? How many B's can you take out?
9.
Again, Kaylee, your voice is coming from everywhere, and I don't know how you're doing it. But you cannot take a B out because the first term does not have a B to take. So all we can take out is a 7. So we divide every single piece by 7. And Connor Clover, what's 28A divided by 7? 4 what? Good. And what's 63AB divided by 7? You're fine. And what'd you say? 9. Not just B, but 9.
AB.
AB. And what's negative 91 divided by 7? Just b? Cubed, right? We're not dividing by any b's, so that stays in there. So that is our final answer there. So look at those first few problems and see what questions you guys have for me so far. Again, we will finish these notes tomorrow with whatever we don't do. I'm going to give it to you guys tomorrow no matter what. Mm-hmm. Whether that means we just work on it tomorrow in class and I help you or what. Okay. So let's continue on. Cassie, what is my GCF of number 1 on that next page? So we can take a 6 out. Can we take any A's? How many? 1. So we can take out 6A. The first one has 2 A's. The second one has 1. So the most we can take is 1 because you can't take 2 from something that only has 1. So the GCF goes out front. RC, we divide everything by 6A. What's 12A squared divided by 6A?
2A.
Good. And what's 6A divided by 6A?
1.
Plus 1. Don't forget to put that plus 1 there. It's going to bother me. All right. Jayla, number 2 is below it. What is my GCF of number 2? The biggest number you take out is 5. Can we take any x's?
Yeah.
How many? So our GCF is 5x, so that goes out front. Okay, Emma, what's 15x divided by 5x?
3.
And what is, just 1 second and I'll answer your question. 25x squared divided by 5x? 5x, good. 2 minus 1 is 1. What's up, Justin?
Could a GCF, couldn't you do more than 1x?
But this one only has 1. Do you see that? Go back to the, the situation that I was talking about before that you guys keep making fun of me about. But I think it works. I think you're understanding it because of that. So I'm going to stick with what I'm saying here. Jordan, what is the biggest number in variables you can take out of number 3, the GCF?
2.
The biggest number is 2. How many A's can you take?
9.
So this one has 2 and this one has 1.
Oh, you can take 1.
You can take 1. How many B's?
2.
2. Okay, I'm going to pause here because variables tend to be confusing. Are we understanding why it's A to the first, B to the second?
Yeah.
Anybody completely lost and need me to explain that to you again? All right. So we have 2AB squared. So Riley, I'm dividing it by 2AB squared. So what's 16A squared B cubed divided by that?
8.
B to the third divided B to the second is?
Isn't that just B to the first?
Yep. And then you do divided by 2AB squared. Again, so what is 2AB squared divided by 2AB squared?
1.
Again, Riley.
Just 1 maybe.
1. And then how many A's? A divided by A is? What?
A.
1 minus 1 is?
0.
So that's 1, right? And then B squared divided by B squared is?
0.
So that's 1 again, right? So what sign would be between these two?
Minus.
Yeah. Okay, Justin Powers. What is my GCF of number 4?
6.
So you can take a 6 out of each of those numbers, and that is definitely the biggest. 12 does not go into all of them. It goes into 24, but not 30. Okay, how many X's? Just a single. And how many Y's? 1. Good, you guys are doing awesome. Okay, Josh. 12xy divided by 6xy is? X divided by x is 1, right? Y divided by y is? So that's just 2, okay? 24xy squared divided by 6xy. 12? 6 times 4. And then how many x's and y's? Just y, okay? And then what's negative 30x squared y cubed divided by 6xy? Perfect. You might finish these. You guys might have all hour tomorrow to work on your homework.
Let me
In the way if we don't.
Yeah, again, still all hour to work on your homework, right, basically. Okay. Grace, what is my GCF of number 5? 3. We cannot take a 9 out of 12, so we have to forfeit that. How many C's? 1 and how many D's? So 3 CDs. So, Mike, if I divide everything by 3 C and D, what's 18 CD cubed divided by 3 CD?
6D squared.
Okay, good. And then what's 12C cubed D divided by 3 CD?
4C squared.
Okay. And what is 9 CD divided by 3 CD? Awesome. Connor. 2 ends. What is the G? Okay, before we do this, we never want our leading coefficient to be negative. So our GCF is going to be negative to pull that out, because a negative times a negative is a positive. So I'm going to pull that out as a negative. So make sure you put the negative there, because our leading coefficient is negative. What goes into 18 and 2, Connor?
2.
How many A's?
3.
How many B's?
6.
Tanari, divide each term by a cubed b to the 6 for me, and tell me what you get when you divide by that negative there. So negative and a negative is a? So 9. Good, and then what's the next term? Plus? 1b to the 3rd, and I'm not going to put the 1 there. Good job, guys. How are you feeling?
Good. This one's easy.